Good morning. My name is Maylene and my partner is Kimberly, and today we're going to be talking about the quadratic function. To start off with, a quadratic function is one of the forms f(x) equals ax squared plus bx plus c, where a, b, and c are numbers with a not equal to 0. The graph of a quadratic function is a curve called a parabola. Parabolas may open upwards or downwards and may vary in width or steepness, but they all have the same basic U shape. And another equation in relation to a quadratic is the parent function known as f(x) equals x squared. Next, we move on to graphing a function. So when graphing the parent function and no equation is given at all, you will plug in the x values. For instance, here we have -3, -2, -1, so on and so forth. So you're going to plug the x values into x squared. Once you do that, it's going to give you what y equals, or f of x. Then those numbers in the chart will equal your coordinates where you will graph them, and it should give you a parabola. For this example, we kept it simple, and here is the outcome of those points.
Now, getting into depth about the intercepts and what kind of symmetry the quadratic function has, the first thing that I will be talking about are the x and y intercepts. X-intercepts are points on a line that touch the x-axis. In the example, there are no x-intercepts. Y-intercepts are points on a line that touch the y-axis. In this case, there are y-intercepts. The intercepts are in coordinates 0, 0. Maximums and minimums are the largest and smallest value of the function, either within a given range or on the entire domain of a function. In the example, there is no maximum but an absolute minimum because it is the smallest value on the function. This absolute minimum is at coordinates 0, 0. Domain and range are the values included in the line, which are the x values and the y values. The domain for the example is infinity and infinity because the arrows are indicating that they are going up. The range is from 0 to infinity because the 0 is included in the coordinates. The end behavior is the behavior of the graph when it reaches negative infinity or positive infinity. This is indicated by looking at the arrows if they are going up or down.
Intervals. This is where you see increase or decrease in the shape, or if there are positive or negative coordinates. For increase, there are only one, and it's 0 and infinity. And for decrease, it's negative infinity and 0. Next, we move on to positive, if there are positive intervals. And there are two for this example, which are infinity and 0, 0 and infinity. For negative intervals, there are none. Next, we move on to transformations, and it's when you plug in a certain type of function notation to the parent function of a quadratic. It will have an effect on the shape of the parabola. First, we start off with f of x plus k, and this is where if k is positive, the function moves up the y-axis, but if k is negative, the function or the shape will move down the y-axis. Next function notation is k times f of x. If k is positive, the parabola opens or closes above the y-axis. But if it's negative k, the function opens and closes below the x-axis, but it's an upwards u. Downwards u, sorry. The next function notation is f times kx, where k stays above the axis and becomes thin or thick. If negative k, then it stays above the x-axis and becomes either skinny or thick as well. Finally, we have f times x plus k. K, if positive, moves to the left on the x-axis, and if k is negative, moves to the right on the x-axis.
To conclude, Real world examples can be a roller coaster, throwing a ball, bridges, a water fountain, and even the golden arches of McDonald's logo.